Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're going to be working on solving and graphing compound linear inequalities. Now, some guides to our inequalities. We need to make sure that we flip the inequality sign when we multiply or divide by a negative number. We use an open circle if we have less than or greater than. We use a closed circle if we have less than or equal to or greater than or equal to. If x is on the left side of the inequality, the arrow points in the direction of the inequality. And on our number line, we're always going to plot the 0 and whatever the number is of the solution. Now, all of our solutions are plotted over the real numbers unless otherwise noted. So here's what I mean by all of this. If we ended up getting our final solution to be x is greater than 5, what I would expect to see on your number line would be the 0, the 5 in the correct spot. Since it is x is greater than 5, it would be an open circle, and we would have the graph pointing off to the right. Okay, so that's what our final graphs are going to go ahead and they're going to look like. So let's see what we can do with these. I want to be able to solve and graph the inequality. So with this first one, I'm going to subtract 2x on both sides, and I'm going to get 2x plus 9 is greater than or equal to 12. To 21. I'm going to step ahead of myself. I'm then going to go ahead and subtract 9, and I'm going to get 2x is greater than or equal to 12. Dividing by 2, I've got x to be greater than or equal to 6. So I have 0, I have 6, it's going to be a closed dot, and it's going to be pointing off to the right. Now looking at number 2, again I want to get the x all by itself, so I'm going to subtract 12 on both sides. I'll have negative 5x is greater than 10. And when I divide by negative 5, I have to flip that sign. I'm going to see that x is going to be less than a negative 2. So I'm going to plot my 0, I'm going to plot my negative 2. It is going to be an open circle, and it will be going off to the left. All right, now some other things I want us to think about is if I were to give you two inequalities and I wanted you to plot them on the same line to create a final solution. Let's go ahead, let's think about what these could look like. If I have x is greater than 5 or x is less than or equal to negative 2. Well, I'm going to plot both the negative 2 and the 5. I'm going to put the 0 on the inside, and then I could say, well, either x is greater than 5 or x is less than or equal to a negative 2. Either one, because this is an or statement, could work as part of my solution, which is why both of those are included in my final solution. Now, if I look at number 4, x is greater than negative 3, and x is less than 4. So I'm going to put my negative 3, my 0, and my 4 up. If it is greater than negative 3, it's an open circle going to the right. If it is less than 4, it's an open circle and going off to the left. Now it has to be greater than 3 and it has to be less than 4, which means I want the overlap here. My final graph is going to look something like this. It's like a little sandwich. It is everything that is in between. All right, take a look at number 5. Number 5, I want x to be less than or equal to 6 or x less than or equal to 1. So I have my 0, my 1, and my 6. Either x is less than or equal to 6, so closed dot, off to the left, or it is less than or equal to 1. It can be either one of these, okay? So it could satisfy either of them. Well, if I only went ahead and chose that top one, I would have all of these values to the right here that would not go ahead and satisfy this or statement. If I chose the bottom one, if x had to be less than or equal to 6, isn't everything on this top line already represented on the bottom line? It is, which is why when we have our or statement, it's going to be the one that goes ahead and contains the most solutions possible. Now looking at number 6, I have x is greater than 3 and x is greater than 8. So here's my 0, here's my 3, and here's my 8. I have an open on 3 and off to the right. I have an open on 8 and off to the right as well. It has to satisfy both of these. It has to be greater than 8 and it has to be greater than 3. Now if I think about these values right here, they're greater than 3, but are they also greater than 8? They're not, which is why when we're talking about an AND statement, we're talking about the overlap. What do the two of them have in common? All right, so let's go ahead and let's formalize this a little bit more here. With these compound inequalities, you're going to have an AND statement or an OR statement. AND represents the intersection. Where do they overlap? The symbol that you'll see for AND sometimes is an upside down U. You can think about that as an AND because you can make the A and continue to write out the word. So the upside down U is our AND statement. OR stands for union. Everything is included. U, the correct direction for the U, stands for our union. It is our OR statement. So let's go ahead, let's see how these are going to work. Number 7 says -4 is less than or equal to 3x plus 5, which is less than 11. You could also say this as -4 is less than or equal to 3x plus 5, and 3x plus 5 is less than 11. This is an AND statement, which means I only want to know where are these graphs going to overlap. Now when we've got a compound inequality like this, notice that we've got 3 places that we are dealing with. I'm still going to solve this just like I would any equation, where I'm going to undo addition and subtraction first. So I'm going to start by subtracting 5 in all 3 spots. And I'm going to see that -9 is less than or equal to 3x, which is less than 6. And then I'm going to divide by 3 in all 3 spots. -3 is less than or equal to x, which is less than 2. First of all, is this a true statement? Is -3 less than or equal to 2? It is, okay? So when we're going to graph these, we're going to graph our target numbers, -3 and 2. We'll put the 0 on the inside. We have a closed dot on -3. We have an open dot on 2. And we want the numbers that are in between -3 and 2. This is what our graph goes ahead and looks like. All right. Now as we take a look at number 8 says 2x plus 6 is greater than 14, or -4x plus 7 is less than or equal to -5. An OR statement means I want everything included. So let's go ahead and let's solve these. I have 2x is greater than 8, x is greater than 4, or -4x is less than or equal to -12, which means x is greater than or equal to 3. Notice that we went ahead and we flipped that inequality sign. When you are writing your final solution here, you need to have that linking word. You need to have the OR there. We need to know that what kind of compound inequality is it going to be. So let's go ahead and let's plot these. I have 0, I have 3, and I have 4. For x is greater than 4, I have an open dot and off to the right. For greater than or equal to 3, I have a closed dot and off to the right. It could be the top one or the bottom one. Everything that is on the bottom is already represented on the top, and since I can have either or means everything gets graphed there. So I have my top equation or my top line as my final solution. All right, look at number 9. Let's go ahead, let's solve this one. I have a union here. Again, union means or. -2x is less than or equal to a -6. Which means x is going to be greater than or equal to 3. Or 2x is less than 10, which means x is going to be less than 5. So here is my final solution here. And if I want to graph that, I have 0, 3, and 5. The 3 has a closed dot on it, and it's off to the left. The 5 has an open dot, and it's off to the right. I want to graph everything. I want the bottom line, or I want that top line. Notice that every single number is going to be represented here. When that happens, this is going to be the set of all real numbers. And that's what I would expect to see next to your number line there. Take a look at 10. Let's go ahead, let's solve this one. I have 2x is greater than or equal to 12, which makes x greater than or equal to 6. Notice I can turn that into an A, which means that this is an AND statement. So x is greater than or equal to 6, and 6x is less than or equal to a negative 12, which means x is going to be less than or equal to a negative 2. So when I go to graph this, I have negative 2, I have 0, and I have 6. It's a closed dot on 6, and it's off to the right. It's an open dot at negative 2, and it's off to the left. And it means I want the overlap. Well, where do these overlap? They don't, which means that this is going to be no solution. And this is what we should be writing on top of our graph then. All right, now look at number 11. Number 11, I have a not equal to sign. We're still going to solve this like it was an equation, so move the 7x over. That's going to give me 5x plus 8 is not equal to 18, which means 5x is not equal to 10, which means x is not equal to 2. So if I've got 0 and I've got 2, well, it can't equal 2, which means there's an open dot at 2. But what can it be equal to? It can be equal to anything else, anything to the right or to the left of it. All right, now the last one we're going to do here, again, we can turn this into an A, so this is an AND statement. As I solve my inequality, I have negative 4x is less than or equal to negative 12, which is going to make x greater than or equal to 3. And solving my second one, 2x is less than or equal to 6, which makes x less than or equal to 3. So as we go ahead and we plot this, we have our 0 and our 3. The first one, we have closed circle off to the right. The second one, we have closed circle off to the left. And means the intersection. It means the overlap. What do they have in common? Well, they only have a 3 in common. And that's what our final graph is going to look like. So keep in mind with our compound inequalities, we have the and statement, we have the or statement. And means the intersection. What do they have in common? Where do they overlap? Or is the union. Everything is included. Del Zadi is done for today. I will see you in class.